Okay, here is the video for example number 3 in section 14.1 on how to use our calculators, our graphing calculators, to find zeros and evaluate in our original function so we're not having to do it by hand. If you look at my calculator, you can see that in my y1 I put my original function, and then I went down to y3 just so there was a little bit of space, and I entered my derivative. So I want you to pause the video. I want you to enter your original function in y1 and your derivative function in y3, just like mine. Okay? Once we got our derivative, remember, we wanted to figure out our critical numbers, where our derivative equaled 0 or didn't exist, right? And so what I'm going to do in my calculator is I'm going to turn off my y1 because I don't want to focus on my original. I really want to focus on my derivative. I'm going to turn it off by going over the top of the equal to sign and pushing enter. And so when you scroll away, you can see that it's not on. The only function that's highlighted and turned on is my derivative, my y3. I'm going to push graph so that I can see my graph. Your window is probably not the same as my window, so let's go ahead and change it by pushing window. And then I just pick some values. I had my x go from 0 to 10. I had my y value go from -2 to 2. And I just kind of played with those numbers. I pushed graph to see if I can see my picture. Because remember, if we're trying to find the zeros, we're trying to figure out where this graph touches the x-axis, where y equals 0. And to me, it looks like it kind of goes down and it touches, goes up a little bit, and then goes back down right here. So what we're interested in is where are those two little places where my function equals 0? Where does it touch the x-axis? And I'm going to have my calculator actually find it for us. Okay, so now that we're in here, we're going to find our zeros by going second, trace. We're going to go down to number 2 to zeros. And on your calculator screen, it's going to ask you left bound. And so I'm going to focus on this first 0 right here. And so left bound means that I want to scroll to the left of that number. So I know it touches somewhere over here, and I want to move my cursor just to the left of that a little bit. What left is really underneath the x-axis, really when y is 0. So as soon as I see this y hitting 0, I can stop, and I'm going to push enter. You don't have to be exact, you just have to be somewhere over to the left or below that x-axis. Now it's going to ask you for the right bound. So remember, we were touching over here somewhere, and I want to now be to the right of it, which would really mean I'm up here above the x-axis, or my y is positive. So if this is my 0 right here, I want to scroll to the right of it somewhere. So do you notice that my y value down here just turned to positive? So now I know that I've just jumped to the right of it somewhere. So as long as I'm to the right, I'm going to push enter. It's going to ask us to guess, and I'm going to push enter again. And so it looks like we have a 0 at 1.72. If you look back at your notes, isn't that the first answer that we got for our critical number? Perfect. Okay, we're going to do the same thing for that other 0. Remember, there was another spot over here where it looks like it also touched the x-axis. So we're going to go second, trace. We're going to go to zeros, number 2. And we want to be to the left of this 0. So I'm going to scroll, 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 scroll. And I want to get really close to it. And if this is up, then down. If it's above and then it goes below, to the left of it is going to be above the x-axis, where y is positive. So that looks good. I'm going to push enter. Now I want to be to the right of it, so the right of this 0 would be down here underneath the x-axis where y is negative. So I'm going to scroll, 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 scroll until my y is negative, and I'm going to push enter. So I have my left bound, I have my right bound, and then my calculator is going to guess and find me that spot. And I ended up getting another 0 at 7.22. And if you look at your notes again, isn't that the second critical number that we got? So perfect. Without having to do quadratic formula, without having to try to factor and do all that craziness, we can now use our calculators to find our zeros for us. So now that we have our critical numbers, remember we want to evaluate those critical numbers and our endpoints in our derivative. Remember our 7.22 critical number we weren't worried about because it was outside of our interval. So we just need to test 0, our first endpoint, 1.72, that was our critical number, and then 4 was our other endpoint. Remember that we're testing those 3 values in our original, not our derivative anymore. So it's important that we go back into our y equals and we turn on our original function and turn off our derivative, because now we're not worried about the derivative anymore. We're worried about our original function. So if you notice, I turned on my original because I want to evaluate those three numbers in my original function. Now that my original is turned on, I'm going to go second, I'm going to go trace, and I'm going to push number 1 for value. I want to find the value of my original function. So this is the graph of my original function now. I want to find the value of my original function when x is 0. Remember, that was our first endpoint. I want to find the value when x is 1.72. And I want to find the value when x is 4. Do you see how quickly I'm evaluating those three numbers in my original? Second, trace values, and then I can enter 0, I can enter in 1.72, and I can enter in 4, all using my calculator so I don't have to do that by hand and make a mistake. And if you noticed on your notes, those are all the same y values that we got before. So now that we have our y values, we can go through and evaluate which one of those is our absolute minimum. And then we can finish our problem. Pretty cool, huh? So now you can use your calculator to find zeros, and you should be able to evaluate functions fairly quickly without having to punch it all in your calculator over and over and over again. I hope that helps. Let me know if you guys need anything else, okay?